All right, so let's finish up with this lesson with angle bisectors, the angle sum postulate, and supplementary angles. Let's talk about angle bisectors real quick. Let's say that we have this angle ABC, okay? And we have this ray BD that sort of cuts in the middle of angle ABC. Now notice what it does. It actually creates two smaller angles. It creates angle ABD and angle CBD, okay? Now, if angle or ray BD is such that when it cuts through the angles, if it causes the two smaller angles created to be equal, we call that a bisector. It is bisecting the angles. See these symbols we use here, this little curve with a single slash through it, a curve with another single slash through it? That indicates that these two angles are congruent. And here's what that means. The measure of the smaller angle ABD is equal to the measure of the smaller angle CBD, okay? And so that means that angle ABD is congruent to angle CBD because they're both the same shape, they're both angles, and they're both the same size. They're the same measure, equal. Same measure, same shape means that the two angles are congruent. If a ray cuts into an angle and creates two smaller congruent angles, then that ray, BD, is an angle bisector. The angle sum postulate says that we can take two smaller angles that are sharing a ray. That means that they are adjacent to each other. The word adjacent means touching, right next to. Okay, so you're sitting next to somebody in class, they're right here. You are adjacent to that person. Okay, well, this angle ABD is adjacent to the angle CBD. And so what we can do is we can take the measure of this angle, this little measure, and we can take the measure of the other angle. We can add those two measures together and it will give us the measure of the big angle, ABC. So if you add the measure of two consecutive angles together, you get the measure of the larger angle, and that's called the angle sum postulate. And we just saw an example of the angle sum postulate when we learned in the last video about a linear pair, right? We said that a linear pair is a situation where we have two consecutive angles, but when you add their measures up, they equal to 180 degrees, and a linear pair exists along a line with an intersecting ray. And so we can say that the measure of this angle right here is equal to 180 degrees minus the measure of this angle, which is CBD. And the measure of CBD is equal to 180 degrees minus the measure of angle ABD. So when we add this angle together with this angle, we get 180 degrees, and the reason we can do that is because of the angle sum postulate. Okay, so if I gave you this diagram, and what this is saying is that this angle FMG is a 40-degree angle. The measure of FMG is 40 degrees. The measure of GMH is 100 degrees. The measure of HMJ is 30 degrees. And the measure of JMK is 80 degrees. If I wanted to know the measure of HMK, I would just add this angle plus this angle. 30 plus 80 is 110 degrees. If I wanted to know the measure of angle GMJ, that's these two angles, I would just do 100 plus 30 is 130 degrees. And if I wanted to know the measure of angle FMH, I would just add FMG 40 plus GMH 100, and that would be 140 degrees. And if I wanted to know the angle of something larger, like FMJ, But on the outside, well, that's a little complicated. It would, this isn't exactly to scale either. But I just wanted to give you an example of how we can use the angle sum postulate. Okay, and so the last thing that I want to mention is what are supplementary angles. Very simply, it has to be two angles. Any two angles, if you add them together, your measure is 180 degrees, then those two angles are supplementary. For example, angle GMH is 100 degrees and angle JMK is 80 degrees. The two of them, because their sum is 180 degrees, those two angles are supplementary with each other. Okay, now this is very similar to linear pairs, except with a linear pair, the two angles have to be touching. With supplementary angles, they do not have to be touching. They don't even have to be in the same country. They don't even have to have the same vertex. You can have a 100-degree angle over in Alaska, and you can have an 80-degree angle down in Jamaica. And those two angles are supplementary with each other because their sum is 180 degrees. Supplementary angles are very important in geometry. We're going to talk a lot about them.